Here is a square. Let me see if it's a square. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it is a square, and it was dilated. And we can tell that it got bigger because the original figure is inside. So you can tell that by the primes. It's A, B, C, D, whereas outside it's A prime, B prime, C prime, D prime. So I know the outside, right? The outside, this guy right here, the outside is the image after the dilation. Okay. So let's look at point A, and I'm going to do this one by one. So point A, from the center, and does it say center dilation 0, 0? ABC is dilated. It looks like it is. Oh, okay. So here's the center. Now, starting from the center, imagine if you had to go to point A, you would walk negative 3, 3 to the left, and 3 up. Point B, 3 to the right, 3 up, which is positive, positive. Point C, 3 to the right, 3 down, which makes it negative. And point D, 3 to the left, and 3 down. All the quadrants are here represented. Now, notice that to go to A, so let me write to go to A, we went 3 left, and then 3 up. That's how you get to point A. Now, to go to A prime, from the center, we're going to go 1, 2, 3, 4, 5, 6. We're going to go 6 left. So to go to A prime, we're going to go 6 left, and hopefully 6 up. Let's just count. 1, 2, 3, 4, 5, 6, and 6 up. What do you notice about the distance? Well, if you look at the distance that you walk on the x-axis, it was 3, now it's 6. And the distance going up, it was 3, now it's 6, so the distance doubled. So we can write that instead of negative 3, scale factor here, it's times 2. So we're going to multiply everything by 2, so negative 6, 6, and you know what, I'm going to go ahead. Well, let me do one more point. Let me pick point C. To go to point C, we go to point C, we go 3 that way, 3 right, and then 3 down. Right? 3 to the right, and then 3 down to go. So this is to C. To C prime is 1, 2, 3, 4, 5, 6 to the right, and then 6 down from the center of dilation, which in this case is 0, 0. So we can write 6 and 6 here. 6 and negative 6, and we can write negative 6, negative 6. So everything doubled, right? The distance you walk on the x-axis, right? And then the horizontal distance that you walk and the vertical distance that you walk, everything gets double. So what's the scale? Well, this is easy, right? Times 2, everything was multiplied by 2, times 2, times 2. What's the rule for dilation? Well, we have our original xy, right? Our original points. And what's happening to each of these points? Well, the x is getting multiplied by 2, and the y is also getting multiplied by 2. So that's the rule for this particular dilation. Pretty easy. Next page. Scale factor is 0.5, and again, this is the important thing. The origin has the center of dilation, meaning everything is based on the distance from the origin to the point. So let's look at, here is the origin. Let's look at point M. To go to point M, I'm going to walk 4 this way, so it's 4 that way, and then 2 units up. 4 that way, and 2 units up. So how do I write this? Well, first of all, 4, negative 4, and positive 2 because it's 2 up. Now, if it's a scale factor of 0.5, right, it's half the distance. So instead of walking 4 that way, what's half of 4? I walk 2 that way. So instead of walking 4, I'm going to go 1, 2. And then instead of going 2 up, what's half of 2? I'm going to go up 1. So there is my first point. M prime is negative 2, comma 1. So we don't even have to multiply. So the first point, M prime is. So what you have to understand is that, right, the distance to get to M horizontally and the distance to get to M vertically got cut in half. Point N, well, to go to point N, you go 2 to the right, and you go 2 to the right, and then 2 up. And if you multiply that by half, or your scale factor is 0.5, you're going to cut that in half. So instead of going 2 to the right, we're going to go 1 to the right. Instead of going 2 up, we're going to go 1 up. So it's 1 up, 1 to the right, 1. And here's point and point. P, sorry, let me write this. So this is 2 and 2. 1 and 1. What is point P? So let me erase this. Point P, if you think about point P, if you want to get to point P, you would go 4 left, right? 4 to the left, and then -4 down to point P. To point P prime, well, instead of going 4 left, we're going to cut that in half. We're going to go 2 left, and then 2 down. 2 left and 2 down. Point O, it's 4 to the right. So think about from the origin, you walk 4 to the right and 2 down. Cut that in half. Instead of going 4 to the right, we're going to go 2 to the right and 1 down. So we're going to go 2 to the right and 1 down, and that's going to bring us here. So point O, what's this? Point O is 4, comma, -2. It's going to be 2, comma, -1. And then point P was, the original point P was -4, which makes it -2, comma, -2. If you connect the dots, you get the same shape. Right? Shape is the same. Right? And the ratio of 2 sides in the original quadrilateral is the same as the corresponding ratio of 2 sides on the figure after dilation. Okay. That's really dilations, right? It's the distance, right? From a point and the center dilation that's being either scaled up or scaled down. Let's take a look at this one. X, Y, and Z. X, let's start with X. So X prime is 4 and 4, -4, comma 4. So to go to X, and here's my center dilation, so it's from 0, I take 4 steps to the left and 4 up. Good, that's very good. To go to its dilated point, it's going to be -6 and 6 up. Now, how did this happen? It's definitely increased, so the scale factor has to be greater than 1. Yeah? So, how do you find a scale factor? How did this become this? So how did this become this? What do I multiply 4 by to get 6? Well, right, the scale factor is 1.5 times. Think about it. 4 times 1 is 4, and 4 times half of 4, it's 2. So if you add those 2, you get 6. Let's look at point Z. Point Z, you go 6 to the left, -6, and 4 down. To get to Z prime, well, it would be 9. 9 left, and how many down? 6 down. Again, if you multiply all these points times 1.5, 6 times 1.5 is -9, -4 times 1.5 is -6, and point, what is this, Y? Point Y is, so think about this, this is easy. If you're at the center dilation, which is 0, 0, to go to Y, you go 6 to the right, so it'd be 6 and 0, right? So what is 6 times 1.5? Well, 6 times 1 is 6, plus half of 6, which is 3. It's going to take us to 9. So, yeah, 9 and 0. Right? taking this distance, which was 6, we're multiplying by 1.5, so times 1 is 6, and what's half of 6? It's 3. So that distance now is we already answered. The scale factor was times 1.5. Everything, all the distances were greater. Scale factor 1.5. And that was it for that sheet. Let's look at the other one. So the other one's a little bit different, right? So it's the reverse side, and the scale, what do you call it, the origin, is not 0, 0. So again, for this, so imagine a coordinate plane, right? So this picture is of, I'm taking a picture of this right here. This is this, right? Because they wanted to save graph paper. First thing, identify the center of dilation, -3, -1. So let's look for -3, -1. Oops. Here's a 0, 0. -3 is -3. Left -3. Here's my center of dilation. Let's do this one by one. Let's look at point A. If I want to walk to point A, I'm going to go 1, 2, 3, 4. I'm going to go 4 units. 4 units, right? But I want 1/4 of 4. So if I take 4 and multiply it by 1/4, it's going to equal to 1. So point A is there. Point A prime is right here. Point B, well, actually not point B. Point B actually, yeah. So here's the center. Let me change colors and make sure that this is the center. Right? Center of dilation. Let's do point C, point B here. Point B again, 1, 2, 3, 4. It's 4 units, right? 4 units. To point B, we want 1/4 of that. Would be just 1 right here. There's C, from the center, we go to C. 1, 2, 3, 4, and again 1/4 of 4. So 1/4 of 4 is 1. So C prime B. This would be the triangle A prime, B prime, C prime with a center of dilation of -3. Right? Next one, what's the center? 4, -2. So from the center, here's the center. 1, 2, 3, 4, -2. Right here. This is the center of dilation. Center of dilation. So everything is going to be based off that point right there. Let's talk about point A, and the scale factor is 2. So we're going to double everything. So look at point A. To get from the center of dilation to go to point A is 1 unit. The scale factor 2, it's going to be 2 units. So 1, 2. So here is A prime. How do you get to B? Well, to get to B, you're going to go 3 to the right. Oops. 3 to the right, and then 1 up, right? Can't count. 2 to the right, and 1 up. 2 to the right, and 1 up. So we're going to double everything. So instead of going 2, we're going to go 4. So 1, 2, 3, 4. And instead of going 1 up, we're going to go 2 up. 1, 2. And here's B prime. C, from the center of dilation, which is the orange, we're going to go 2 left, and then 1 down. 2 left. To go to C, we're going to go 2 left, and 1 down. So let's double that. So instead of going 2 left, I'm going to go 4 left. 1, 2, 3, 4. 4 left, and then 2 down. That's C prime. So the image, right, the dilation of scale factor 2. Dilation, scale factor 3, so that's triangle is going to be 3 times as big. Where's the center of dilation? Center of dilation is here, 0 and 3, 0, 1, 2, 3. Here's my everything is going to be based on the distance from that the point is away from that from the center of dilation. So from the center, let's do A. If you go from the center, you go 1, 2, 3. That's 3 units. So multiply 3 times 3, we get 9. So 3, 4, 5, 6, 7, 8. What in the world? One, two, three. Oh, that's because I made a mistake. Sorry. This was not working. So center dilation is not. It's zero. This is 0, 0, 1, 2, 3. It's here. Okay, sorry, that was my mistake. Center dilation. Okay, start again. So from the center dilation to A is 1, 2. So if I multiply 2 by the scale factor, which is 3, the new distance is going to be 6. So A prime is going to be 1, 2, 3, 4, 5, 6. Here's A prime. Right? We have the original distance multiplied by 3, 3 plus 6. Let's go B. How do I get to B? I go 1, 2. And again, so from the center of dilation, that 2 units, again, we're going to multiply by 3. It's going to be 6. So 1, 2, 3, 4, 5, 6. Here's B prime. C prime. Well, from the center of dilation to go to C, I go 2 left, 1 down. I go 2 left, 1 down, right? To go to C. Now, to go to C prime, we're going to take these two numbers and multiply by 3. So 2. We're going to take this guy here and multiply by 3. It's going to give us 6. So we're going to go 1, 2, 3, 4, 5, 6, and then we're going to multiply this by 3. 1 times 3 is 3, so then we're going to go 3 down. 1, 2, 3. And here is C prime. So again, if you connect the dots, you're going to see that this is the same triangle, same shape. Okay. What was the scale factor of 3? Dilation, the scale factor is 4, so it's going to be 4 times bigger. Right? So the center is D2 negative 1. So 2. And here's the center of dilation from there. So center. This is my center. So from the center to go to A is 1. If I dilate that distance, it's going to be 4 now. So 1, 2, 3, 4. Here is A. Change colors. To go to C, well, from the center of dilation to go to C is 1 unit. So now I'm going to multiply that by 4. So it's going to be 4. So 1, 2, 3, 4. Here's C prime. To go to B is 1 left and then 1 down. So to go to B, I have to go 1 left and 1 down. Right? But we're going to multiply each of those by 4. So I'm going to go 4 left, 1, 2, 3, 4, and then 4 down. 1, 2, 3, 4. That's going to be B prime. Join that. Notice, look, my side BC, which was 1, is now B prime C prime, which is 1, 2, 3, 4. Right? All the side dimension, all the dimensions are also increased by scale factor of 4. 5. Okay. Last 2. Scale factor of a half. What happens if the scale factor is a half? Well, it's going to get smaller. By how much? By half. Where's my center? Center is negative 1, 3. Negative 1, 3. So negative 1 to the left and 3 down. And 3 up. So here's my center. My center. Right. So let's start with B because that's easier. So if you look at B, it's 1, 2, 3, 4, 5, 6. And 6, what's 6 times a half? 6 times a half is 3. So B prime, it's not going to be that distance is going to be half that distance. So 1, 2, 3, and here's where B point is. Point C. C is 6 to the left, right? To go to C is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So we got to cut everything in half. So going left, so 6 to the left and 4 down. So cut that in half. So instead of 6 left, we go 1, 2, 3. And instead of going 4 down, we go 1, 2. Here is C point. Finally, A. How do we get to A? Well, to get to A, we gotta go from the center. 1, 2. So to go to A, we're gonna go 2 that way, and then 1, 2, 3, 4, 5, 6, and 6 down. So if we cut it in half, instead of 2 to the left, we're gonna go 1. Instead of go 6 down, we're gonna go 3. So 1, 2, 3, and there is. Notice that the shapes are exactly the same, obviously, because we use a scale factor of half. It decreased. Last question. It's going to get a scale of 1/3 now, okay, which is sorry, nothing. D 4, 2, 1, 0, 0, 0, 1, 2, 3, 4, and 2. So here's my center of dilation. Everything's going to be based on the distance that the points are to that center of dilation. Let's look at point A. If you were at this center and you had to walk to A, you would go 1, 2, 3 units. Right? So it's 3 units. But the scale factor is 1/3. So 3 times 1/3 is just 1. So let's get that back. Erase that. The distance was 3, and we want 1/3 of it. So 1/3 of it is just 1 unit. And ta-da! Here's my A prime. C. Well, C, how do I get to C? It's 1, 2, 3, 3 to the right, and 3 up. So it's just multiplied by 3, it's just 1. So instead, C is going to be 1 to the side, 1 to the left, and 1 up. So here is C prime. B, from the center, right, from the center, how do I get to B? It's 1, 2, 3, 4, 5, 6. 6 left, and then 1, 2, 3 down. So what's 1/3 of that? Well, 1/3 of 6 is 2, and 1/3 of 3 is 1. So we're going to go 2 to the left and 1 down. So from the center, blue, the blue point right there, which is 4, 2, we're going to go 1, 2, and then 1 down. And here is point B prime. So let's connect the dot. And that's our new shape. It's that easy. Really, it's that easy. Oh no. What did I just? Oh.